All right, so we've already talked about the graphs of each of these parent functions. We've talked about their domain and range, and we've talked about the name. For the most part, all we've put into the special functions area or special things area is the name of these functions. Today we're going to add a couple more things to that. We're going to talk about their x-intercepts and y-intercepts. We're going to talk about their symmetries, if there are any. We're going to talk about minimums and maximums at a specific location. And we're going to talk about asymptotes, again, if there's any. Okay? All that stuff we're going to add in this special section. If you want to draw this pretty love, you can. Otherwise, it's fine. Okay? But all that's going to go over here in the special things. All right? So let's start with this function, which we know is called linear, because it makes a line. Tell me about the x-intercept of this function. Okay, so earlier they said to me the x-intercept is at the origin. Is that wrong? No, but it's not specific. Okay? I mean, I don't know of any other graphs where the origin is any other place than 0, 0, but it's just a semantics. All right? So if I ask, where's the x-intercept? Oh, I can't write in pencil. You can't see it. Where are we going to say our x-intercept is? Our x-intercept is at 0, 0. Where's our y-intercept? Wait, it's at the same place? Are you sure? Good. So y-intercept and x-intercept is at 0, 0. So let's talk about symmetry. Are there any lines of symmetry?
No. Well, yes.
Yes? Where?
If you did. No, if you did.
So like right here?
Yes.
If I folded this along that line, would those be right on top of each other?
No.
No?
Yes. Oh,
If I folded it just like this, like that, would those be right on top of each other? I didn't draw anything. I just put my pen right like that. Okay? What about a minimum? Is there a minimum on this graph of this function? No? Correct. The lowest number, the lowest point on this particular graph. Is there one?
No.
Because? It's continuing. Okay? What about a maximum? No, because it's continuing. It continues. Okay? Is there any asymptotes? No. Okay, so are we done with this one? Yes. Second one. Quadratic. It's a quadratic function. It makes a parabola. That's the shape that it makes. Does it have a y-intercept? Does it have an x-intercept?
Yes.
Are they the same?
Yes.
Where are they?
0, 0.
So the y-intercept and the x-intercept is at 0, 0.
Did we write like one line of symmetry over number 1 or something?
Nah, it's fine. I meant to say no, ma'am. Sorry. Ma'am.
Can we write in like a different color? So
Sure?
Can I do this with this?
Yes,
No.
that's fine. For now. Lines of symmetry. The y-axis. So right there. So we don't want to say the y-axis. We want to write the equation of that line. So the equation of the y-axis, remember horizontal and vertical lines, we say which axis it's crossing and where. So which axis does the y-axis cross? And where?
0.
0. So we have a line of symmetry at x equals 0. Is there a minimum? There is? Where? 0, 0, right? Because it's and then it stops, and then it starts going up again, right? It's coming down, it's decreasing, and then increasing. So that is the minimum. Zero, 0. What about the maximum? Where's the maximum? There's not one? Is that what you said? Will there ever be a maximum? Is there ever a maximum on any quadratic function? Oh yeah, if we flip it over, right? Okay. But today we are specifically talking about parents, right? Parent functions. Will there ever be a maximum on a quadratic parent function? No. Okay. But keep in mind there are maximums on quadratics depending on if they're reflected or not, right? Okay, good job. Look at this one. Now, there was a discussion. I don't want to say argument because that sounds mad. Okay? So there was a discussion about what this is called. Now, what she's got written on her paper is cubic. Someone else had written on their paper cube. I know it's the same thing. They did not. And we're speaking with slightly raised voices about it. Are we okay with the fact that it's either called a cube or a cubic? Are we good with that? Okay, good. So let's start down our list. Y-intercepts and X intercepts. Does it have one? One of either? Does it have one of either? Where are they? Both of them? Okay. Y-intercept and X-intercept at 0, 0. Symmetry. Do lines of symmetry only have to go this way or this way? No, they can go any way, right? Any direction. There's no way that I can put a line on this that will give me a reflection? No, there's not. Okay? What about a minimum? Because it's continuing. What about a maximum? Okay, so now I'm going to ask you a trick question. Are you ready? What if I restricted my domain to between -1 and +1? Is there a minimum? Yes. Where is it? -1, -1. Is there a maximum? Where is it? 1, 1. So anytime I want to, I can just restrict my domain. Okay? A lot of times we restrict our domain to positive x values. Because if we're talking about a word problem, we typically assign our x value to be time, and our y value might be money or all sorts of different things. Okay? So I might typically restrict my domain to positive x values. Is there a minimum here? Where is it? 0, 0. Is there a maximum? No. Okay? So, like, can you just randomly decide, I'm going to restrict my domain and here's my minimum and maximum? Not really, right? There's usually a reason why we restrict our domain and range. Okay? Or, I might restrict your domain and range just because. I might say, here's your parent function, but restrict your domain to not be -infinity to +infinity, but -1 to +1. If I do that, then you can find minimums and maximums, can't you? Okay? Any questions about that? Yes, ma'am. Does it matter if the line is curved or straight? As far as minimum and maximums go? Is that what you mean? No, it does not. Good question. How are we doing so far? Okay, so we said X and Y intercepts are at 0, 0. We said there's no lines of symmetry. We said there's no minimums and maximums. What about an asymptote? Not in this graph, right? There's no asymptotes here, is there? Okay? Next page.
Can I ask a really dumb question?
If it is truly a dumb question, I will tell you that it's a dumb question and usually not answer.
What are asymptotes?
That's not a dumb question. Okay? It's been a couple days since we talked about asymptotes. We talked a little bit about them on the first day, and I know that because it's written on her paper down here in a little while. Okay? An asymptote is somewhere on a graph that nothing can live. There's no values. A lot of times when we're doing asymptotes on our table, we get an error. Okay? But just to be clear, when we get to some of these functions, some of the specific functions that do have asymptotes later on, we get very specific about asymptotes, and you'll know exactly what they are.
Yes.
Or really exactly what they're not.
Thank you.
Yes, ma'am. Okay? All right, so square root functions, sometimes known as radical functions. Okay? Y-intercept, X-intercept. 0, 0. Okay. Y-intercept and X-intercept. Oh, I didn't make sure that everybody knew that meant intercept. You okay with that? Okay. 0, 0. And also for the record, just a small commercial break, I always have thought, I can't see it, that it looks like an owl.
How does that look like an owl?
How do you look like an owl?
Like his eyes.
How do you not see the owl?
That looks like a very surprised people.
Okay, I'll go with that too. Okay. Okay, so X-intercepts and Y-intercepts is at 0. What about symmetry?
No.
No symmetry? You're sure?
Yes, I'm sure about that.
Yes.
Good. What about a minimum? 0, 0 is the minimum? Is it okay if I use min to represent minimum? Guess what I'm going to use to represent maximum? Is there a maximum?
Nah.
Nope. What about an asymptote? Yes, there's an asymptote. Where?
Everything below 0. All the negative numbers.
So an asymptote is a line. And just so you know, there's not an asymptote here. Okay?
Oh,
Yeah.
okay.
Okay? Cube root functions. X and Y intercepts.
0,
0,
0.
0. Whoops. I'm seeing a pattern. So should I just write that on all the rest of them?
No.
Well, you just said they're all that way.
So far, they're
Oh, so far. Okay. 0, 0. Oh, sorry. Thank you very much. X and Y intercepts. Okay. Symmetry.
yes.
Wait a second.
If we could fold it twice, if we could put 2 lines on there, could we find a reflection? Yes, we could, but it's called a line of symmetry, not lines. Right? Okay? Well, I guess I have been saying lines, but whatever. Ignore that part. Okay. Minimum and maximum. If I restricted my domain, I could find them, right? Okay. Asymptotes. No asymptotes. All right, next one. One of my favorite ones.
This one has an asymptote.
X and Y intercepts. What? They get closer and closer to the axes, but they never touch, right? So there's no X and Y intercepts, and we're going to make a specific note of that. No X or Y intercepts. What about lines of symmetry?
Yeah, there's one here.
Oh yeah, there's one? Where is it?
Negative.
So like right here?
Yeah.
Uh-oh, I better do something else or I'll get judged on my lines of symmetry. Like that? So I'm going to go ahead and put y equals negative x because that's the equation of that line. I'm going to put line of symmetry. And then I'm going to listen to what she had to say. And she said, couldn't I do also one on positive x? Can't I do one here also? Y equals x. Line of symmetry. What about, oh, is there any more? Are those the only two? I think so, probably. Okay. What about minimums and maximums? Only if I restrict my domain. Okay. So no minimums or maximums. What about asymptotes? So where's an is there only one? There's two? Okay. So one is here. I'm trying to draw on the axis, but if I draw exactly on the axis, you can't see it. And then there's one here, right? Remember we talked about that the other day? Now, just like before when we said we don't want to just say that the X and Y-intercepts is the origin, we want to be real specific and call them specifically by name. We want to call these asymptotes by name as well. Okay? What's the name of this asymptote? Y equals 0. I know that that's the x-axis, that it's a horizontal line, and we name horizontal and vertical lines by which axis they're crossing and where. This is crossing the y-axis at 0, so the equation of this line is y equals 0. Okay? What about this one? X equals 0. So I have asymptotes at x equals 0 and y equals 0. Questions? Where do we start? X and Y-intercepts? Do I just have those memorized that that's what we're talking about today? I mean, I think it's awesome that you think I do, but I also wrote them on the board. I'm just reading them off the board. Okay. Okay. So, X and Y-intercepts first. There's not one? Either one? There's a Y-intercept right there, isn't it? It crosses the Y-axis right there. So, my Y-intercept, 0, 1. And you're sure there's no x-intercept? And never crosses the x-axis? Okay, what about symmetry? Is there symmetry right here? Like this way? No, okay. It's close-ish, kind of, but not really. Okay. Minimum? Gets close but doesn't get there, right? Okay, what about maximum? No, so only if we restrict the domain, right? Okay. What about an asymptote? There is one. Okay. And we figured that out kind of a second ago when we were thinking about the fact that it gets closer and closer to 0 but it never touches. That's pretty much what an asymptote is, right? It gets closer and closer to that, but doesn't touch. So where is my asymptote? Good. Any question? How about 8? So there's another y-intercept, right? Where's my y-intercept? My y-intercept is at 1? Like that? Oh, 0, 1. Okay. 0, 1. X-intercept? Not 1. Lines of symmetry? Minimum? Maximum? Asymptote? Okay, good. There's an asymptote. Y equals 0. Good. Look at number 9. Y-intercept. X-intercept. So our Y and our X-intercept is at 0, 0. Symmetry. Oh, there is one this time? Where? Minus symmetry is at x equals 0. So right here, right? Crosses the x-axis at 0. Minimum. Oh, there's a minimum. 0, 0. Maximum? No. Will there ever be a maximum? Will there ever be a maximum on any absolute value function?
Wait. Yes.
If we reflect it, right? But again, we're talking specifically about parents. So will there ever be a maximum of an absolute value parent function? That's even a trick question, because, right? What if I restrict my domain? Can I restrict my domain on a parent function? Yes. Okay. I'll make that clear if I decide to do that, though, okay? Asymptotes? No? Okay. Come back here. We didn't do these, did we? Okay. It wasn't time to get to logarithms. I want to show some of this to you today. Okay. So this is going to be weird on the recording because the recording is only going to see the paper. But I want to be able to show you guys in the room some stuff. Which means I need to go here. Okay. It's still seeing the paper. So I'm going to transfer some stuff onto the paper. So when we go back to the paper, you'll be able to see it too. Okay. This says log base 2 of x. So looking on the paper, we're talking about problem number 10, log base 2 of x. Okay? Where is it crossing the x-axis? So it crosses the x-axis at 1. Let's go back here real quick and fill in the table. Okay? 0, 1, 2, 3, 4, 5. 2, 5. So if we had a calculator right now and I could show it to you on the screen, you would see that log base 2 of -5 is an error. And log base 2 of -4 is an error. And -3 and -2 and -1. These are all errors. Okay? And log base 2 of 0 is also an error. I just realized I had a calculator right here, so I'm just going to show you. Here you go. See, all the negative numbers are errors. Okay? 1 is 0. 2 is 1. 3 is 1.584. I would say 585 if we're going to round correctly, which we should. 4 is 2. And 5 is 2.322. So if we graph just this, it looks like this is what's happening, right? Something like that. Except when I showed you the graph, even on the calculator, that's not what's happening at all, is it? What happens right here? Does it stop right there? Does it? It doesn't stop right there, does it? What it looks like is it stops, but that's because of the restrictions of the calculator and the size of their pixels, right? So what's happening to this function? Closer and closer to 0, but not touching. Okay? So draw that somehow for yourself. And if you look at this one I have up on the screen here, it's a little bit easier to see. Okay? So let's talk about the domain of this function. What's the domain? How far left does it go? How far right does it go? Does it include 0? Because it never touches it, right? So here's one way. X is greater than 0. What do you think the other way is? 0 to infinity. What's on the 0, though? A parentheses. Good. What about the range? Really? Good. All real numbers? Negative to positive, right? So, first of all, what's this called? Logarithmic. X and Y-intercepts? X-intercept is at 1, 0. Whoop. There's not a Y-intercept. Symmetry? No symmetry. Minimum? Maximum? No? Asymptote? Oh.
What's there be a minimum?
Would there?
It could never reach 0.
It can never go left to 0, but how far does it go down? An infinite amount. It just never reaches 0. It just gets closer and closer. Okay? And then asymptote, we said yes? Where? X equals 0, right here, right? Okay. So what about the next one? Whoop. Calculator. I'm going to make this log is 10. So that's what it looks like on the calculator. Does it look the same? Kinda, right? Okay, so let's look at the table. Control T. So, guess what happens to all the negatives? Guess what happens to 0? 1, 2, 3, 4, and 5. Well, 1 is 0. 2 is 0.301. 3 is 0.477. 4 is 0.602. We're going to change the 5 to a 10. Let's guess what the 10 is going to be. Now, the base up here was 2, and look what 2 was. 1. The base up here is 10. Guess what 10 is? 1. So this one crosses here, and then here. So it still does that thing right there, but it's real kind of shallow right there. So is it going to have a different domain and range than number 10? Different or the same? X is greater than 0, 0 to infinity. All real numbers, negative infinity to positive infinity. So what's this one called? Still logarithmic, isn't it? X and Y-intercepts? X-intercept at 1, 0. No Y-intercept. Is there any symmetry? Is there a minimum or maximum? No. Is there an asymptote? Okay, where? Last one. Control T, get rid of the table. Log base E. Does it look any different? A little bit, right? So we kind of have a general idea of what to expect. So all these are errors. Guess what 1 is? 0. .693, 1.099, 1.386, and 1.609. So I know it's there. 2 is a little more than half. I'll go out to 5.6. Domain, range, same as before, right? X is greater than 0. So 0 to infinity. All reals and negative to positive. What's it called? Logarithmic. Anyone going to ask me about the base? Isn't E a variable? Isn't it a letter? Isn't that supposed to be a variable? Except there was a guy who lived a long time ago and he's dead now. Leonard Euler was his name. Euler? Yes, Euler. Excuse me, Leonard Euler. and you spell his name like this, and you pronounce it Euler. Oh no, nobody asks me. Okay. And he discovered a number that's naturally occurring in nature, and guess what he called that number? E. He called it E. And we use it especially when we get to logarithms. Exponents and logarithms, we use that E a lot. Okay? We usually write it in script to show us that it's not just some random variable that we're using. That's what a base we're using here, is that number E. Okay? Have a great day.